Hi, everyone. Welcome back. We are in grade 5, unit 3. We're on lesson 2. And I got to tell you, as I was preparing for this video, I started thinking this one might be one of my very favorite lessons ever. And the reason is because, well, you can see I've got a bunch of stuff, but here's the reason. Right at the top of the page, it says visualize the steps. And you know, and you heard me say over and over and over and over and over that math is to be done. It's not to just be written down on a piece of paper. Math is part of our life. And we should have tools, we should be using materials. And when it specifically tells us to visualize, that means we should be thinking about visualize is what you do in your brain. It's like making that movie in your brain. But it's a lot easier if we actually have materials. And so you see, I collected a book. One of the questions is about how many pages in a book. I collected materials. One of the questions is about building. So I've got some bloxels and one of the questions is just numbers. And when we think of just numbers, it's really helpful for us to make those numbers into something. And then, of course, I got my some of the things we can't really maybe model out, like driving 80 miles. So I've got my paper, in this case, my whiteboard, so I can draw that out. We are visual learners. Many of us learn a lot about the world by what we see. Not only that, but we're also physical learners. When we interact with materials, it really helps us understand the concepts better. So please, if you're new to me as a teacher, or if you are new to the idea that you can have materials with you, please pause this video at any time and go collect something. And it doesn't have to be fancy math materials, maybe that we have at school. I mean, if you have Bloxels, go get them. That's what I'm using. My sons are letting me borrow them, or Legos, or rocks, or go out and collect something outside that you can use. Find a book. There are so many materials, and they don't have to be specific to math, but they will help you. So that's why this is one of my favorites, because it encourages us to visualize what's going on. Numbers are not just numbers. They always mean something. If you're ever stuck, pause and picture something in your mind. Say, okay, I'm going to make a purposeful effort. And it's not what people automatically do, but it's what you can do as a fix up strategy. And as you get better and better and better, you'll find that you maybe do start automatically doing it, which is really cool. But if you're not already doing it, when you see 1/3 of 24, if you don't automatically think of something, get 24 of something. That's what my dice are for. So I'm going to get 24 of them and then divide them into thirds to picture it in my mind. And I really encourage you to do the same. So let's get started. Okay, I'm on page 87 of our SAB. If you've already completed the SAB and you're working on the practice pages, it's absolutely fine. You can still watch the video and think about these and then go and apply them to the practice pages. If you haven't completed these student activity book pages, this is a perfect opportunity to do that. So number 6 says, if 1/7 of a book is 4 pages, how many pages is 2/7 of a book? So if you say, oh, I automatically know that, good for you, fantastic. You're probably starting to understand fractions a little bit better and multiplying with fractions. But regardless, grab your book. Here's my book, What If Everybody Did That? If you haven't read it, incidentally, it's a really good book about being personally responsible for yourself in ways that help other people. So if I said 1, 2, 3, 4, 4 pages is 1/7. Well, what if I did another 4 pages? 1, 2, 3, 4. There's another 1/7. So the question said, how many pages is 2/7? Well, we flipped through 4 pages for one. We flipped through 4 pages for the second one. So how many pages is 2/7 of the book? The answer is 8 pages. Did you know that one? All right, number 10. Remember, you can stop this video at any time to work the problem out before you and I work it together, and that's a really good strategy to learn. So number 10 says, Eagle Rock is 72 miles away. So we're apparently going from wherever we are to Eagle Rock. We had gone 2/9 of the distance when we stopped for gas. How far have we traveled? Now, this is one that you can picture in your mind because everybody's going on a car trip. So you can picture yourself piling into your vehicle with your family. You got all your stuff. Sometimes you're like totally overloaded. If you're going on a big trip, you even wonder if people are going to fit in the car. And you start driving and you're going along and you need some gas. So you pull over, get some gas, maybe you get a treat from the gas station, and then you continue. So you can be picturing this. This is the visual part. You can be picturing this in your mind. The hard thing is it's hard to act this out, right? I mean, unless I took my video camera and actually drove 72 miles and then put it on super, super fast speed, you wouldn't want to watch that on the video. This is a good time to not necessarily act it out, but definitely draw it out. So pause and draw this out. I'm going to do the same, and when we get back, let's see if our pictures match. Okay. Does your picture look a little bit like mine? Well, hopefully it looks a little bit, probably different, but hopefully you have that long distance from 0, we're starting at our house, that's 0, to Eagle Rock. It tells us it's 72. Now, you might have thought of Eagle Rock as a town or something. I actually pictured it as maybe a place that you would go hiking up to, like a spot maybe where eagles were nesting. You could take your binoculars or something. So how you pictured Eagle Rock is completely fine, and how you pictured your house or your place that you're starting is completely fine. But the important part is you do want to have yourself starting here at your house. You want to have Eagle Rock, and you want to make sure that you're telling us that it's 72 miles. Now, the question is, if we had gone 2/9 of the distance, well, how would we know how far that was? Well, hopefully you're saying to yourself, it's about fractions. It says it's 2/9. Remember the denominator, that 9, the denominator tells us how many chunks the whole thing is cut into. So we have to cut it into 9 different chunks. This distance, we have to cut into 9 chunks. So if you've already done that, good for you. I haven't yet, so I'm going to pause and do that. Now, something common that happens to a lot of kids is they say, I don't know how to cut something into 9. I kept erasing and then moving and erasing and moving, and it was so frustrating. And I get that. It's not an even number, so it's hard. So let me show you my strategy. It's not the only strategy, but it is a good one. It works well for me. So let me show you my strategy for cutting something that's an odd number. First, I know that I need 9 sections. So the very first thing I do is I go to the very center, what I think is the center, right there, and then I don't put a line in the center. That would be an even number. Only even numbers have a whole number line in the center. Instead, then I put lines around the outside of the center. There's my center, but I drew these 2 lines. There's one section of my 72 miles. Now, the section in between this line and 0 is an even number. I need 4 of them. So then I draw a line in the center, I cut it in half, and then I cut that in half and that in half. Then I do the same thing over here. The right-hand line of where I drew it, the middle chunk, to the end, again, from this line to the end, I again need 4 more sections because I started with 1, then I put 4 over here, now I need 4 over here. So I'm going to put a line in the middle, which lines in the middle are a lot easier, and then line in the middle, line in the middle to get my 9. So that's a good strategy to try if you're having a hard time knowing how to cut something like into ninths, which is a hard one. So now that we're done cutting it into each of these sections as we're driving along is 1/9. So 0 to 1, there's 1/9. This one to this one is another ninth. This one to this one is another ninth, another ninth, another ninth, another ninth, etc. So it said we had gone 2/9 of the distance when we stopped for gas. So here's where we started. 1, 2. I'm going to put a little gas pump here. There's the holder. and I'm gonna write gas, although my marker is so fat, I don't know if it's gonna work. Well, it's a little bit. So there it is. Stopped for gas at 2 ninths. How far have we traveled? So we know that this is where we stopped, but how are we gonna know how far that was? Well, hopefully you're saying, oh, well, if we're cutting it into ninths, I know a math fact that is nine, uses nine and ends at 72, or continues actually. What is that fact? 9 times something equals 72. 8. 9 times 8 is 72. So if 9 groups of 8, remember times means groups of, 9 groups of 8 gets us 72 miles, that means we started at 0. The first group is 8 miles. Remember, it's fractions. The denominator has to be equal groups. So each of these is 8 more miles. Every time we get to one of those hash marks, we've gone 8 more miles until we finally have gone 72 miles. So the first one, we've gone 8 miles. After the second one, how many total miles have we gone? 16. So that's another 8, but you could also total it as 16. The third one is another 8 miles, but you could total it at 24. You could do another 8. You could total it at 32, and you could keep going. So, how many miles was it that we'd gone when we'd gone 2 ninths? We'd gone 16 miles. Now, we're going to get to a time where they're going to just start giving us numbers, not a whole scenario so we know how to just draw it out. So let's kind of think about that before they do it for us to see if we can figure out what that's going to look like. So then maybe we can use this picture of driving and going somewhere to help us when we just see numbers. So 2 ninths of 72. 2 ninths of, we'll stop there a second, 72 is 16 miles. Notice how some of those words have mathematical connotation. That means they mean something in math. 2 ninths, we wrote that, of. 2 ninths of 72. Do you remember what the word of means in math? Groups of. That means multiplication. So when we say we've gone 2 ninths of the distance, that actually means multiplication. Times means groups of. And sometimes they don't even use the word groups, they just use of. So 2 ninths of 72 is, I should have left that out because I gave you too big of a hint. What does is mean in math? It means equals. So 2 ninths of the 72 is 18, or I'm sorry, 16. If you can think about what those common words that we use commonly like that, how they translate into mathematical connotation, which means like how we write things in math, what they mean, you're going to be in great shape. Let's come back for the next question. Okay, we're on number 13 on page 88. Here's an example. Remember, I was telling you, sometimes they're just going to give us numbers. When they start just giving us numbers, that's extra important for us to start thinking we've got to use that strategy of visualizing and not only just making a movie in our mind, but if you can, actually literally build it out. So we've got the problem 1/3 of 18. Sometimes kids see 1/3 of 18, they say, how would I know that? I don't know what that means. Because partly they haven't stopped and actually built that out. If you build it out, you'll figure it out. And same thing with 2/3 of 18. So you need 18 of something. So pause the video and go find 18 of something. It doesn't matter what it is. It can be 18 spoons or silverware, like forks, knives all together. It can be 18. You could go out and find 18 little rocks, 18 little chunks of stick. It doesn't matter what it is. Go find 18 of something and then start the video again. Okay, I'm back too. I found 18 dice. If you watch other videos, you know my family, we love dice. There's a lot of fun games, not only like math fact games, but just a ton of games that are kind of fun that you can play with by yourself, with one person, with a whole group of people. So we enjoy just playing with dice. So we've got a bunch of dice, and I have 18 of them here. Now I need 1/3 of 18. What did we just talk about of means? It's part of groups of. 1/3 of a group of 18. So we need 1/3 of a group of 18. That's also 1/3 multiplied by 18. Those are all different ways of writing the same thing. But we need 1/3 of a group. Well, how are we going to know what 1/3 of a group is? It's really important that you're starting to understand what the denominator means. The denominator means it's cut into 3 groups, and not 3 groups like this. 1, 2, 3. That's not it. It has to be 3 equal groups. So what you're going to do is cut those 18 dice into 3 equal groups. Now, if you know a math fact that will help you with that, you can just count it out. If you don't know a math fact that can help you out, you can sort it out. There's 1, there's 2, there's 3 equal groups. Put another one here, another one here, another one here. It's fair so far. Whoops, you can't. Oh, there we go. Can't see that. Now you can. Now we go another one, another one, another one, another one, another one, another one. Keep doing this, giving each one until you sort it out. So now you changed in a group of 18. You put it into 3 equal groups. How much is in each group? Well, again, if you know a math fact that can help you, that's going to be really, really helpful. You know that there's 6 in each group. So we need 1/3, 1 out of the 3 groups of 18. How much is 1 out of the 3 groups of 18? Well, hopefully you're saying, well, that's easy. There's 6. 1, 2, 3, 4, 5, 6. I'm taking this one group out of 18. Is 6. What about 2/3 of a group of 18? Well, then that means you're choosing 2 groups. So you say, I'm choosing this group and this group. So now how many have I chosen? Now I've chosen 12, twice the number that I had before. So 2/3 of a group of 18 is 2/3 times 18 is 12. And we figure that out by acting it out. Okay, this is the last one we're going to do together today. This is number 18, and it gives us a table to look at of the heights of buildings. Now, this is tricky because it doesn't actually tell us what the actual heights are. In fact, it gives us a variable, a letter. In math, remember, letters in math just mean something that we don't know. It means a number, it's just a mystery number. We don't know what it is. So it tells us that the bank is a mystery height, and they're using the letter N. Remember, we can use any letter at all. It doesn't matter which letter we use. So the bank is the mystery height, the number of stories, they're using N. The bus station is 1/6 times N. When we see that multiplication sign, we know that means 1/6 of a group of N, 1/6 of the group. Think back to the video with my sons and I when we were doing those things outside. I went 1 length of the parking lot. One son went 3 lengths of the parking lot, 3 groups of it, and one went 1/3 of the length. Think about the slack line. I went 1 length on the slack line. My one son went 4 lengths of the slack line, 4 groups of that. My other son went 1/4 of the length of the slack line. So when we say 1/6 of the height of the bank, is it going to be more or less? Hold on to that idea. Sports shop is 5/6 of n. 5/6 times n. 5/6 of a group of n. Again, is that going to be more or less than the height of the bank? And then what about the hotel? The hotel is 6 times n. 6 groups of n. Is that going to be bigger or smaller? Well, let's model it out and see if you're right. So this is where I'm going to use the Bloxels. Now you might be saying, how could you possibly model this out, Miss Gubrud, since we don't know how tall it is? We don't. But I see that we're going to cut the number, that's the actual number, we're going to cut it in 6. So I'm going to start by building the bank 6 high. That doesn't mean it's actually 6 stories. It might be a multiple of 6. It might be 6 or 12 or 18 or 24 stories high. We don't know. Sometimes banks could be huge. But we're going to just start by modeling 6 high for the bank. So I'm going to do that off camera so you don't have to watch me do it. Okay, so I used orange, and there's my bank. I just made it 6 stories tall. Now, that doesn't mean that's what it is. We don't know. It's a mystery number. It tells us it's a mystery number. But I'm going to make it 6 stories tall. So hopefully you also grab something Legos or something you can stack up. And so you're not just watching me play with math, but I hope you're also playing with math. There's the orange bank, 6 stories tall. Now, the bus station is 1/6 of n, which is the bank. The bus station is 1/6 of how tall this is. Do you see why I chose 6? It's a lot easier. If I chose 5, it'd be really a lot harder. So the bus station is 1 out of 6 pieces. Well, hopefully you're saying, easy peasy lemon squeezy. 1 out of 6? Boom. That's how tall the bus station is. All right, so I'm going to pause and write the bus station in blue. There it is. So we have a mystery number, is how tall the bank is. 1 out of that amount is the bus station. 1/6 is the bus station. There it is. The sports shop is 5/6 of however big the bank is. 5/6. So 5 out of 6 pieces of this n. How are we going to build that? Well, hopefully you're saying, 5 out of 6. So I need actually 5. 1, 2, 3, 4, 5. It's 5/6 of a group of the whole thing. 5 out of 6 pieces, 5/6 of how tall the bank is. Okay? And lastly, the hotel is 6 times n, how tall the bank is. 6 groups of how tall the bank is. Well, think about that. It's 6 groups of however tall the bank is. That's going to be pretty tall. So I need to use something I haven't. I'm going to use red, but it's going to take me a minute because 6 groups as tall as this was already 6. So I need 6 groups of 6. How tall is this hotel going to be? Let's see if you're right. Okay, well, you maybe chose some better materials than I did, but these are really hard to stack that tall. I tried it a couple times, they kept falling all over the place. I should have had a fast motion video. So here's how tall the bank is, a mystery amount. The blue station is 1/6 of that, so it's only 1 out of 6 pieces of this. The yellow is 5/6 of that, so it's 5 out of the 6 pieces. And the hotel is 6 times that. So I only got 2 times to stack. I couldn't get anything else. But all of the rest of these right here that I built, they all need to stack on top. So if you think about, this is 2 out of the 6. So another 2 and another 2. They would have had to be this tall off the table. And I tell you what, Bloxels are not made to do that. Should have chosen Legos or something. But you don't necessarily have to be super successful even with your modeling out to be able to understand what's going on here. The hotel is ridiculously tall compared to the bank, And that's pretty tall compared to the bus station. And the sports shop is almost as tall as the bank. I hope this is helpful for you. Good luck with the rest of the questions or the practice page. We'll see you next time.